Ever heard of the OSI model? You know, that thing that helps us understand and design network architectures and protocols? It's a conceptual framework that standardizes the functions of a telecommunication or computing system into 7 abstraction layers. These layers, they're like the building blocks of communication, each with its unique role, working together to facilitate smooth and efficient data transfer. The International Organization for Standardization, or ISO, they're the ones who developed this model. Their goal? To make sure different systems and devices can communicate, no matter their underlying hardware or software. It's like a universal translator, breaking down the language barrier between different technologies. So, whether you're a network engineer or just someone who's curious about how your devices talk to each other, the OSI model is your go-to guide. So, now you're probably wondering, what are these layers we're talking about? Let's start from the bottom, with the physical layer. This layer is the ground floor of our 7-story OSI model building. It's all about the tangible, the hardware, the physical connections that make data transmission possible. Think of the physical layer as the foundation upon which our data superhighway is constructed. It's concerned with the nitty-gritty details that often go unnoticed, such as the type of cables used, the connectors, and the network interface cards. Also, it oversees the electrical and mechanical aspects of data transmission and reception. Essentially, it's responsible for converting binary data into signals and transmitting them over the network. But what's a good highway without some traffic rules, right? This is where the data link layer comes in. As the second layer in the OSI model, the data link layer acts as the traffic manager of our data superhighway. It's tasked with creating a reliable link between 2 directly connected nodes. This layer ensures a smooth ride for our data frames over the physical layer by providing error detection and correction. If a data frame encounters a pothole, so to speak, the data link layer is there to patch things up and get the data back on its journey. And it doesn't stop there. The data link layer also plays a crucial role in controlling the flow of data to prevent congestion. It uses techniques like flow control and error control to ensure that data frames don't collide with each other on their way to their destination. It's like a traffic cop, making sure that data travels safely and without interruptions. In a nutshell, the physical layer and the data link layer lay the groundwork for data communication. They ensure that our data bits have a proper road to travel on and that they obey the traffic rules. They're the unsung heroes of the networking world, tirelessly working behind the scenes to keep our data moving. These 2 layers are all about making sure the data bits get from one place to another. But how does it know where to go? Enter the network layer. This is where the magic of connecting devices on different networks happens. The network layer is like a skilled postmaster in a bustling city, responsible for logical addressing, routing, and forwarding of data between devices. It ensures that data, packed neatly into packets, is sent from the source to the destination across multiple networks. If the physical and data link layers are about getting the data bits and frames across, the network layer is about knowing where they're headed. Now, imagine a world where every packet is a letter. Each letter needs a destination address, right? That's where logical addressing comes in. It's like the postal address on your letter, guiding it to the right destination. But that's not all. The network layer also takes on the role of a traffic controller, deciding the best route for each packet to reach its destination, a process known as routing. And then comes forwarding, the act of moving the packets along the chosen route. But what happens when the packets face a bump in the road? That's when the transport layer steps in. Consider the transport layer as a reliable courier service. It manages end-to-end communication, ensuring that the data is transferred reliably and efficiently between devices. It's tasked with error recovery, flow control, and retransmission of lost or corrupted data. If a packet gets lost or damaged during transit, the transport layer rolls up its sleeves and arranges for the packet to be retransmitted. And in the case of congestion where too many packets are trying to reach the same destination at once, the transport layer steps in to control the flow of data, preventing a traffic jam in our data highway. In essence, the transport layer is all about ensuring a smooth and efficient journey for our data packets. But it's not just about getting the data to the right place, it's also about making sure it's properly organized. That's where the session layer comes in. Do you remember the last time you logged into your email account or streamed a video online? That connection you established is managed by the session layer, the fifth layer of the OSI model. This layer is like a skilled event planner, coordinating communication sessions between applications. It's not just about starting these sessions, but also maintaining and eventually winding them down. Think of it as a conversation between two people. The session layer initiates the conversation, keeps it going, and when it's time, brings it to a close. It's the layer that ensures that data from the application layer above it is properly organized and presented for transmission. But what about the data itself? How does it get translated into a format that the application layer can understand? That's the role of the presentation layer, the sixth layer of the OSI model. This layer acts as an interpreter, translating data between the application layer and the lower layers. Imagine you're at a foreign film festival. You don't speak the language, but you're still able to understand the movie thanks to subtitles. That's what the presentation layer does for data. It translates the data into a format that the application layer can understand. Moreover, the presentation layer isn't just a translator, it's also a protector. It ensures the security of your data by encrypting it before it's sent over the network and decrypting it when it's received. And if your data is too large to be sent in one go, the presentation layer steps in to compress it, making sure it gets to its destination efficiently. So the session layer and the presentation layer work together to ensure that your data is correctly organized, translated, and secure. They play a critical role in the seamless operation of the network communication process, making sure that the conversation between your device and the network is effective and efficient. Finally, we get to the layer that you as an end user interact with the most. The topmost layer, the application layer. Often considered the most relatable layer for most users, the application layer is the seventh and final layer of the open systems interconnection model. It's the layer that's closest to the end user. And it's here that network services are provided directly to applications and end users. Think of an email client or a web browser. These applications need to send and receive data over the network, right? That's where the application layer comes into play. It facilitates these data exchanges, enabling communication between software applications. It's the layer that allows you to browse websites, send emails, and chat online. Now, let's take a step back and look at the big picture. We've journeyed through the 7 layers of the OSI model, starting from the physical connections at the physical layer, moving on to the reliable link between nodes at the data link layer, and the routing of data across multiple networks at the network layer. We then delved into the transport layer, which ensures data is transferred reliably and efficiently. We explored the session layer, which establishes, maintains, and terminates communication sessions between applications, and the presentation layer, translating data between the application layer and the lower layers. And finally, we've arrived at the application layer, connecting network services directly to applications and end users. Each layer, with its specific function, contributes to the overall process, ensuring seamless communication between systems and devices. In summary, the OSI model is a conceptual framework that helps us understand and design network architectures and protocols. It's a modular approach that facilitates interoperability between different networking technologies and devices. While it's a conceptual model, it's invaluable for understanding how different network components interact and how data travels from one system to another. So there you have it, the OSI model in a nutshell. Each layer playing its part to ensure seamless communication between systems and devices. Remember, the OSI model is a conceptual framework. It's an invaluable tool that helps us break down complex network architectures into more manageable parts. This modular approach is what facilitates easy interoperability between different networking technologies and devices. Each layer of the model handles a specific function, allowing us to isolate issues, enhance functions, or even innovate within that layer without disrupting the entire system. While the model provides a great foundation for understanding, it's also crucial to note that it doesn't directly correspond to the architecture of specific networking technologies. For instance, the Internet, which we use daily, follows a similar but not identical model known as the TCP/IP model. The OSI model is, in essence, a language that allows network engineers to communicate effectively, ensuring that the digital world stays connected. Thanks for joining us on this journey through the layers of the OSI model. Keep exploring and you'll uncover even more fascinating aspects of network engineering.